Hello and welcome to medicinal chemistry classes. Today we will discuss about local anesthetic. Local anesthetic. The local anesthetic are the synthetic drug which produce the loss of sensation in a particular applied area for clinical purpose by blocking the sodium ion entry inside the cell membrane, which is required for the generation and conduction of nerve impulse. The local anesthetic are mainstay of analgesia because they prevent the initiation and propagation of the electrical impulse required for the peripheral and spinal nerve conduction. The clinical and surgical procedure can be performed under regional anesthesia rather than general anesthesia. The chemistry for designing the local anesthetic. The local anesthetic contain aromatic cream which play important role for hydrophobicity properties which help to cross blood-brain barrier. Hydrophobicity increase both potency and the duration of action of local anesthesia. Local anesthetic. The local anesthetic contain amine or its derivative which are required for the hydrophilic properties. Amine derivative and aromatic part of local anesthetic must be linked by linker chain which may be functional group or alkyl chain. So this is the chemistry of local anesthetic. Next, the ideal properties of local anesthetic. It should be stable in the solution and under group biotransformation readily within a body. The local anesthetic must be inert. Next property is the local anesthetic should be non-irritating to the tissue. The local anesthetic must be free from producing allergic reaction. Next property is it should have sufficient penetrating property and provide a rapid onset action. Next ideal property is pharmacological action of local anesthetic must be reversible and not to produce any secondary reaction or action. It should have minimum index of toxicity and should not produce any synthetic toxicity. So this is ideal properties of local anesthetic. Next is SAR or structural activity relationship. The local anesthetic agents structures having three parts mainly. First is aromatic ring, also known as lipophilic ring or lipophilic substituted ring. Next part is linker chain, either an ester or amide. Next is amine group, that is your secondary amine or tertiary amine or amino-alkyl group. So this is the three part of your local anesthetic agent structure. This is the structure of your local anesthetic. Okay. Next, the part first, the aromatic ring. First part. The aromatic ring are substituted at different position, mainly adds lipophilicity to the anesthesia or anesthetic and enhance the penetration power through the biological membrane. The aromatic ring and their substitution position may cause increase in the lipophilic nature of aromatic ring. The substitution on para position of aromatic ring in ester type of local anesthetic increase the ability of molecule to penetrate the nerve membrane and increase their affinity at the receptor site. Okay. So because of aromatic ring, the penetration power of local anesthetic is increases. Next, it increases the lipophilic nature of drug, and also it increases the nerve penetration on nerve membrane and increase the affinity of receptor site. So this is the or next, the electron donating substituents such as alkoxy or amino or alkyl amino at para position are more potent and show increased anesthetic activity. Means the substitution of electron donating group on the para position, it increases the anesthetic activity. This is because of the electron donating group on the aromatic ring create resonance between the carbonyl group and ring, resulting in the shift of electron from the ring to the carbonyl oxygen. Okay. So because of aromatic ring, it increase the penetration power. Next, it increase the lipophilic nature, or also increase the ability of nerve membrane, penetration of nerve membrane and affinity of receptor site. Next, the electron donating group substitution on para position or at para position, it increase the anesthetic activity. Okay, so this is all about aromatic ring. As the electron cloud around the oxygen increase, it increase affinity of binding the molecule with receptor. This concept was proposed by Bucci and Perley. When the aromatic ring was substituted with an electron withdrawing group, the electron cloud around the carbonyl oxygen decrease and anesthetic activities decreases. Means when the substitution of electron donating group, it increase the anesthetic activity, and substitution of electron withdrawing group, it decreases the anesthetic activity. Next, part 2 regarding the local anesthetic structure is the linker. The linker may be carbon, oxygen, nitrogen containing functional moiety or functional group, mostly ester or an amide type with hydrophobic chain of various length. So this is the structure of your local anesthetic. When the linker having alkyl chain with increased number of carbon, the lipid solubility, protein binding, duration of action and toxicity increases. Biosteric replacement of ester and amide enhance the activity. In an isosteric procaine series, anesthetic potency decreases in the following order: sulfur, oxygen, carbon and nitrogen. The similar in their structure means the ester and amide having similar binding property and usually differ only in the stability in vivo and in vitro. The duration of action and toxicity associated with drug or affected by biosteric modification like amide are more resistant to metabolic hydrolysis than the ester. In the series of procaine or its analogous, branching at the alpha carbon will increase duration of action, and lidocaine or its analogous does not show this effect. Okay. So alkyl chain with increasing carbon, it increasing the carbon of the lipid solubility, means it increase the solubility, protein binding, duration of action, and also increase the toxicity. Next part of local anesthetic structure is amino alkyl group. The amino alkyl group for making the drug water soluble, not necessary to anesthetic activity. The order of substituted amino alkyl group is more important for the activity. That is, tertiary amine derivatives are more potent and less toxic than the secondary amine. Okay, means the substitution of tertiary amine group, it increases the activity, but the substitution of secondary amine group, it decreases the activity as compared to tertiary amine derivative. But secondary amine may increase the duration of action and also it cause irritation. Secondary amine increases the duration of action but it causes irritation. However, primary amine are not suitable for local anesthetic as less However, primary amine are not suitable for local anesthetic as less active and highly toxic as compared to secondary and tertiary amine. Some drugs have amino group is absent. They are active but have poor water solubility, example benzocaine. The potency will be diminish if the derivative use more hydrophilic substituent like morpholino group. This is all about your local anesthetic SAR. Okay, thank you.